Hi there, this is a geometry video, just having a look at volume this time, just running through a quick revision on volume. What formula would you use to find the volume of a rectangular prism? Length times breadth times height. So if you had a quick diagram of a rectangular prism, we would take the length and breadth and height and multiply them together to get the volume of that shape, that three-dimensional solid. Volume of a cube, side length cubed, because if we're just doing volume, we're multiplying the length, breadth and height, and in this case, in a cube, they're all the same as each other. We've got the side length there, we've got the side length there, and the side length there. So in a strange, quirky way, we have the same side length times itself again, which creates that cube up the top there. Volume of a cylinder, pi r squared times h. Now it follows the prism sort of idea that a volume can be gained by finding the area of an end that sort of goes through the whole shape, what they call a cross-sectional area, and that would give us pi r squared for the circle bit, times by how far back it goes or how far down it goes. So if we found the area up here of pi r squared for the circle, times by how far down it goes, we've found the volume of a cylinder. So that makes sense, that one. Volume of a sphere, 4/3 pi r cubed. And so we need the only thing we need for that, the only measurement we need is the radius of the sphere here. I'm not sure how to make that look like a sphere rather than a circle. Not very good at drawing, as you've seen in my other videos, but still. 4/3 pi r cubed, once we know the radius, we'll be right for that one. Volume of a cone, 1/3 pi r squared h. Those of you who are just listening on the volume of a cylinder would recognize the pi r squared h as being the volume of a cylinder. I'm fascinated by the idea that for a cone, if you put a cone in a cylinder, as in made a cone by putting a dot on the top circle of a cylinder and joining that down to the bottom edge there, that cone, the volume of that cone, the air sort of taken up by that cone section, is 1/3 of the whole cylinder. Exactly 1/3. It blows my mind that it's so even. Exactly 1/3 is the cone section and of the full cylinder. So this box bit would be the full cylinder, and the cone's 1/3 of it. Alright, there's some quick reminders of how volumes operate, and hope that quick revision helps your brain to remember some of those features. All the best, see you next time for some more maths videos, peterblakemaths.com.